A very good morning to you all. Sorry, I'm just trying to figure out how Mr. Dick can stand and speak. I'm going to talk to you about why, how, and what of Chandrayaan-3 and Aditya L1 missions. To start with, I just would like to introduce to you myself and where do I come from and what is the kind of research background I have. So I'm trained as an astronomer and astrophysicist. Did my PhD in the Indian Institute of Astrophysics and spent a lot of my time, research time, in the observatory of Kavalur, looking at the night sky, studying the stars. And I'm still, given a choice, would like to go back and spend time looking at the night sky. And I was inspired by the night sky I saw when I was a kid, and brilliant stars, constellations, and comets. Aditya L1 and Chandrayaan, which is not there in this particular picture, but then I'm sure most of you would have seen this picture, which is coming from the very phenomenal James Webb Space Telescope. So this is the deep sky image of the sky, which is, you can see galaxies which are like twisted and turned, like, you know, somebody called it as a Rumali roti. So it's all sorts of things are there, and these are happening because of, you know, gravitation, deep space things, etc. So things you see on the sky are projected and they are very far away. So now we can see extremely far away objects using this marvelous telescope up in space. Now, if you can see so far and so in the early form, when the universe was formed, in the early times, etc. Now, why are you trying to go to the moon? And why are you trying to study the sun, which is extremely close to you, right? So the paradox over here is that you are in the Earth. How much do you know about the Earth? A little bit, not much. You don't know what is inside the Earth, what is causing the earthquakes. So start from there. So there are a lot of unknowns which you start from, right from your own Earth. And then you take them, how did you form? How was the solar system formed? How was the moon formed? What does this have? Is it different? Why is Mars different from Earth? Why is Venus so different from Earth? You know, these questions we do not understand. And of course, like the chair pointed out, where did the first cell form? What was out there? Where did it come from? Why do we have so much of water on the Earth? So these questions are very local. We need to understand how the planets or the situation around you to take it forward, understand what is out there. But it doesn't stop. Like, you can't say that just because I do not understand enough of around you, you cannot look beyond. But there are certain things you get from beyond and you apply here. It's vice versa. So these kind of pursuits go all over, and I would like to point out that astrophysics has immensely been, advanced a lot in the last 2 to 3 decades due to two things. Astronomy is a technology-driven science. So technology drives it, point number one. Point number two, data democratization and software availability. Because people, when I was doing PhD, you have to go to an observatory to collect data and try to learn from the analysis techniques there to do something. But now you have data publicly available, you have decent amount of computing facility from your laptops. Normal laptop has a decent facility. You have lot of software which is public, open source, and data. You can actually do research. Now, what do we do in Indian Institute of Astrophysics? These are the various centers of Indian Institute of Astrophysics. So I'm the director of Indian Institute of Astrophysics. Not that I do everything what is done in the institute, but I know kind of what is done over there. We have campuses in Bangalore, rural and urban. And I just want to separate it out because the main campus is the most of the faculty sit in the urban campus, but the campus in the rural, which is in Hoskote, is where we have integrated the space instrument. So what is the USP? Yeah, we have ground-based facilities as well as space-based astronomical facilities. What do you mean the facilities? Below there is hydroxyl molecules. Now we could not actually understand this hydroxyl of water, but needed more studies. Then people went back and started establishing that yes, it is correct by multiple methods, and infrared detectors became more popular and more able to understand the water molecule separation. So this was a 3 micron, 6 micron was identified to actually said it is actually water present. H2O is there, not only OH. So how was it formed? Is it actually a remnant or something comet falling on it is creating? It's still a question mark. Now that, and also the minerals out there, to a possible formation of, you can actually capture, make it into hydrogen and fuel, and as a stop station to, other explorations started coming up. So that is when Chandrayaan 3 is most important, because these kind of changes in thinking and the global scenario and the Artemis missions, Artemis planning actually has changed the landscape in the last 5 years or so. So Chandrayaan 2 did not have landing properly, but then the landing was very important to one, technologically demonstrate that we can do it, two, we can actually say that we can carry out experiments and get the data. So this is very important step. And I'm not going to repeat what is actually known. You have seen a lot of things, a lot of articles are there in the web. So the other point, the cost effectiveness, against all odds. Just like how we, succeeded in developing vaccine with very little facility or infrastructure. Again, the same thing here. So you have to lift up with a very large weight. We can't do that. But we still find a way to actually lift off larger weights and reach moon. So there's no prize in giving you the first prize in reaching the moon the fastest, right? That's not the idea here. How do you effectively do it? So this is the way in which you actually, take larger and larger orbit and then push it to moon and take again a number of orbits and then land. So that's the reason why it takes more time to land there. But then the longer is better, but then you have to do it right. That's what is the most underlying thing, is you have to do it right. And you also should remember each requires enormous amount of calculation, precise calculation. If you miss one orbit and one correction not done properly, the other orbit is increased, and you'll actually miss the entire thing. So it's accurate, precise calculation and execution. So this is the bottom line of the slide. Now what do we do here? Since this is a kind of a very risky endeavor, you can't put too much of complexity in there. So you have to minimize the complexity, but make sure that they work. So these are simple experiments, but very important, because understanding the plasma on the surface of the moon. Second is that's the number. Chastity is to actually measure the temperature, because you know that if